Welcome to another episode of Mastering Cybersecurity, developed by baremetalcyber.com. Let's dive in. Mobile application security means keeping phone and tablet apps trustworthy, predictable, and hard to misuse, even when devices move through messy real-world conditions. The scope includes native apps built in platform languages, hybrid apps that mix native code with web content, and apps that rely heavily on embedded web views for screens and workflows. iOS and Android approach some details differently, but the shared goal is protecting people, data, and services from avoidable harm. Strong mobile security matters because phones hold personal histories, business data, and access to payment and health services that criminals value. A small mistake in how an app stores a file or talks to a server can quietly snowball into identity theft or company breaches. Treat this episode as a map of the moving parts, the common risks, and the steady practices that prevent small slips from becoming serious incidents. A mobile app lives in a layered architecture that starts on the device and stretches into the cloud. On the device, the app runs inside an operating system sandbox that isolates its code and data from other apps and enforces permissions. Local storage might include databases, files, preferences, secure credential vaults, and transient caches created by the framework or libraries. Over the network, the app calls back-end services through an application programming interface, API, that expects specific inputs and produces structured outputs. Those API calls often rely on authentication, session tokens, and rate limits to keep access controlled and orderly. Observability completes the picture because logs, crash reports, and telemetry help diagnose issues without exposing sensitive information. Protecting data at rest begins with understanding where data might silently end up. Sensitive information can leak into files, databases, framework caches, screenshots in the multitasking switcher, system logs, or even the clipboard if developers are not careful. Use platform-secure storage services such as the iOS keychain and the Android key store for secrets, tokens, and encryption keys that should never sit in plain files. Minimize what is stored and how long it is kept, because every extra copy is another chance for disclosure during device loss or repair. Disable sensitive views in screenshots where possible and keep debug logging free of personal details or tokens. When storage is deliberate, minimal, and shielded by the correct platform features, recovery from incidents becomes faster and less painful. Protecting data in transit relies on well-understood techniques and consistent verification. Transport Layer Security, TLS, encrypts traffic between the app and backends, but its strength depends on correct certificate validation and careful handling of error conditions. Certificate pinning is a technique where the app remembers a specific certificate or public key and refuses connections that do not match, which reduces the risk of man-in-the-middle interception on hostile networks. Pinning should include planned rotation paths so routine certificate updates do not break the app in production. Public Wi-Fi remains risky because captive portals and rogue hotspots can tamper with DNS or inject content before TLS is established. When failures are handled conservatively and diagnostics avoid leaking secrets, network protection becomes sturdy under everyday travel and enterprise conditions. Good authentication and session handling make identity reliable without making usage frustrating. Passwords should be supported by multi-factor authentication, MFA, that adds something people have or are, such as one-time codes or platform biometrics. Sessions typically rely on tokens that prove identity for a limited period, so token lifetime, renewal, and revocation need clear rules that match the risk of the data. Keep tokens in platform-secure storage rather than in plain preferences, web view storage, or logs that attackers might read. Use distinct tokens for different services when possible, and avoid reusing tokens across staging and production environments. Clear sign-out flows and device-level protections, such as passcodes and screen locks, close the loop and prevent stale sessions from outliving user intent. Code and secret handling deserves patient discipline because small conveniences can create big weaknesses. Hard-coded keys, credentials, and server addresses often ship into production accidentally, where they become permanent gifts for anyone reversing the app. Basic obfuscation raises the cost of reversing but cannot replace real controls that protect backends with authentication and authorization checks. Tamper detection can spot rooted or jailbroken devices and modified app packages, which helps decide when to restrict sensitive actions or degrade risky features. Secrets should be injected at build time or delivered by secure configuration channels, then stored only in approved credential vaults. When developers favor clarity and testability while still avoiding exposed secrets, the system becomes both easier to maintain and harder to exploit. Cryptography in mobile apps works best when teams use proven tools with conservative settings. Choose platform libraries and reputable wrappers instead of custom cryptographic code because subtle mistakes can silently erase protection. Key management is the art of creating, storing, rotating, and retiring keys so encryption remains meaningful under real failures. Strong randomness is essential for tokens and nonces, which means relying on platform-secure random functions and avoiding predictable seeds. Algorithms and modes should be modern and authenticated because confidentiality without integrity invites quiet tampering. With these habits, encryption moves from comforting decoration to verifiable protection that stands up during incident response. Third-party components power many features and deserve supply chain attention equal to their convenience. A software development kit, SDK, for analytics or advertising might introduce broad permissions, background network calls, and data collection behaviors that conflict with user expectations. Keep an inventory of all SDKs, versions, and declared permissions, and review their update notes with the same seriousness given to platform updates. A software bill of materials, SBOM, lists the components inside the app, which helps during incident response and compliance reviews. Limit data sharing to what features truly require and avoid stacking multiple SDKs that compete for the same capabilities. With an explicit inventory and periodic reviews, you keep features while avoiding silent drift toward unnecessary risk. Healthy build, testing, and release hygiene converts security ideas into repeatable outcomes. Static analysis, often called static application security testing, SAST, examines code and configurations for dangerous patterns before the app runs. Dynamic analysis, often called dynamic application security testing, DAST, probes a running build to surface issues such as missing headers, weak cookies, or injection risks. App signing proves origin and integrity, while staged rollouts reduce blast radius by exposing changes to a small group before wider release. Monitor crashes and security signals together so issues linked to permissions, storage, or network failures are triaged with context. When each release repeats these steps and captures results, the team grows quieter confidence that security is not accidental. Mobile apps operate within broader organizations that manage devices, policies, and expectations. Mobile Device Management, MDM, enforces configurations like passcodes, disk encryption, and managed app catalogs that reduce risks from lost or non-compliant devices. Policies can disable copy-paste for sensitive apps, restrict backups, or require network tunnels for corporate traffic that carries regulated data. Apps can detect jailbroken or rooted devices and respond by reducing access to high-risk functions while still offering safe read-only experiences. Bring Your Own Device, BYOD programs benefit from clear boundaries that separate personal and work data without intrusive controls. When app controls and organizational policies reinforce each other, people keep their flexibility while sensitive data keeps its protections. Risk never stands still, so teams need feedback loops that keep the picture current. Privacy reviews align data collection with documented purposes and retention periods, which prevents surprise behaviors that damage reputation or violate laws. Security reviews should touch permissions, storage, networking, cryptography, and third-party components, then record decisions so future contributors understand trade-offs. Incident exercises rehearse actions for lost devices, stolen credentials, or compromised certificates, which shortens real recovery times. Community bug reports and responsible disclosure programs invite outside eyes to find what internal teams missed before attackers do. With these loops in place, small improvements arrive continuously, and the overall posture becomes stronger without dramatic overhauls. Performance and reliability influence security in subtle ways that beginners sometimes overlook. Slow or flaky network calls tempt developers to add logging and retries that might accidentally capture tokens or personal data. Caching improves responsiveness but must avoid storing sensitive pages or files that a different app or user could read. Background tasks that sync data should respect power states and connectivity changes, because retries on insecure networks can reveal patterns to eavesdroppers. Error messages should remain helpful without exposing stack traces, internal identifiers, or server details that map your environment. When performance optimizations include privacy and security checks, the app feels faster and safer at the same time. Accessibility and usability are part of security because confusing designs cause risky workarounds. Consent prompts should be written in plain language that explains the benefit and the risk of granting a permission at that moment. Authentication screens can support biometrics and password managers to reduce typing errors that lead to lockouts or predictable passwords. Clear indicators of secure connections, trusted domains, and verified actions help people spot phishing flows that mimic account screens. Thoughtful recovery paths for forgotten credentials or lost devices reduce pressure to reuse passwords or store them unsafely. When the design respects human limits, people choose safer actions without needing expert knowledge. Testing on real devices and realistic networks exposes issues that emulators and office Wi-Fi sometimes hide. Try roaming between cellular and different Wi-Fi networks, passing through captive portals, and operating under throttled bandwidth and high latency. Validate that the app refuses unsafe connections, redacts sensitive logs, and recovers gracefully after interruptions or clock drift. Practice returning to health after deleting tokens, rotating certificates, or clearing caches, because real users trigger these conditions frequently. Record findings in a shared place where developers, testers, and product owners can see patterns and address root causes. With realistic testing, surprises shrink and the app behaves predictably when the world is unpredictable. Regulated environments add extra documentation and traceability that can also help unregulated teams. Payment, healthcare, and education apps often need explicit data maps, retention schedules, and audit trails that show who accessed what and when. Even when not required, keeping lightweight diagrams of data flows, permission justifications, and third-party inventories helps new team members make safe changes. Coordinating security and privacy reviews with release planning prevents last-minute scrambles that introduce rushed fixes or risky deferrals. Vendor contracts for backends should include expectations for uptime, incident notification, and key rotation to keep shared responsibilities clear. With traceability in place, questions during audits become routine confirmations rather than stressful investigations. Mobile security succeeds when small, consistent practices reinforce each other across the app, the device, the network, and the backend. Permissions are requested with context and kept minimal. Storage is deliberate and shielded, and network connections are verified and fail safely. Tokens are handled carefully. Cryptography is chosen conservatively, and third-party components are inventoried and reviewed. Builds are scanned, releases are staged, and behavior is observed without exposing secrets or personal details. With this mindset, teams steadily reduce avoidable risks while preserving the speed and convenience that make mobile applications valuable. Strong mobile security feels calm, predictable, and durable because it is built from many careful choices. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.